Welcome to Math 1314, Section 2.8. In this section, we're going to look at how do we combine two functions together. And there's actually 5 ways to do that. The first way is to form a new function called f plus g. And how does this new function work on the input x? Well, you simply put that x into f, you put that same x into g, and then you add up the results. Another way is to form f minus g of an input, and the way it works is exactly the same way. You put the x into both f and g and do the operation that combines them in the middle. The third way, is f multiplied by g, and this works just like the first two. You put the x into f, you put the x into g, and then you multiply the two things together. And the fourth way is f divided by g of x, and you put the x into f, you put the x into g, and then perform the division. Now, this works so long as g is not 0. Because if g were 0, it would make the whole thing undefined. So these are the easiest of the 4 ways to combine two functions. We'll see the 5th way a little bit later in the problems. So looking here at question 1, we have an f, we have a g. We want to form f minus g where x is 4. So f minus g of 4 is simply f of 4. We're going to get that number. We're going to get g of 4, and then we're going to subtract the results. So what is f of 4 and what is g of 4? Well, f of 4. F is here. 7 times 4 is 28. What about g of 4? Well, g is this absolute value, so 4 minus 6. Absolute value of minus 2 is 2. So we've got 28 minus 2, and we get 26. In question 2, we have new f, new g, and we want to form f multiplied by g of 4. So we simply put the 4 into f, I put the 4 into g, and then we multiply the results. So what I need is f of 4, and I need g of 4. F of 4. Well, go find f. Here's f. Minus 3 times 4 is minus 12. And g of 4 is absolute value 4 plus 2. Absolute value of 6, which is 6. And so we've got 12 minus 12 from the first, 6 from the second, multiply them together, and we get minus 72. All right, in question 3, we have an f and a g and an h, and we want to find g plus h of minus 1. So I put the minus 1 into g, I put the minus 1 into h. And then we see what comes out. So g of minus 1. Well, g is this absolute value, all right? So minus 1 minus 6 is absolute value of minus 7, which is 7. And h of minus 1. Well, here's h up here. So 1 over minus 1 plus 4, and I get 1/3. So we have 7 plus a third, or 7 and a third. So to get a common denominator, you multiply 7 top and bottom by 3 over 3. I get 21 over 3 plus 1 over 3 to give me 22 over 3. All right, in question 4, we have an f, a g, and an h, and we're trying to find f divided by g of 0. So 0 goes into f, 0 into g. I just have to hope that g of 0 is not 0. Well, let's see. What is f of 0? That's 6 times 0. Here's f up here. So that's 0. G of 0. G is this absolute value. So I get 0 plus 3. Absolute value of 3 is 3. We get 0 over 3, which is 0. Okay, 0 on the top is fine. We just don't want 0 on the bottom. In question 5, we're looking at g divided by f of 7. Alright, so I need g of 7 and I need f of 7. Well, what is g of 7? 7 plus 3 is 10 and absolute value is 10. F of 7 is 6 times 7 is 42. Now I notice I can at least divide a 2 into both of them, and so I get 5 over 21. Alright, in question 6 we have p minus r of x. So here they didn't give us a number, it's a generic x. Well, it works the same way. It's p of x minus r of x. So you see I'm keeping together, here's p and here's r. So minus a minus is plus 7x, and when I combine these together I get x squared plus x. They ask us about the domain and the domain here is everything. Now the reason for that is the domain is what's in common between each of the separate domains. So p of x is this quadratic, its domain is everything. Okay, so the domain here is everything, and for r it's everything as well. So they both have exactly the same stuff in common, and so the domain for the difference is all real numbers. Now in question 7 we get something new, which is called function composition. It looks like f circle g of x, which is f of g of x. So what they want us to find is f of g of 3. Think of it this way. The 3 is on the inside. So 3 is sitting here. It's going to go into g. Well, g is square root 3 times x. So 3 times 3 is 9. Square root of 9 is 3. So the output of g now is chained or funneled into the input for function f. So the two functions are kind of lined up. The output of one becomes the input of the next. So g of 3 is 3, and now 3 goes into f. So here's f. F is x cubed minus 3x. So when I plug in 3, I get 27 minus 9, which is 18. So again, composition combines the functions so that the output of one is the input of the next one. All right, in question 8, we have h of f of 3. So the 3 goes into f first. So what is f of 3? Well, 3 cubed minus 2 times 3. So 27 minus 6, and I get a 21. All right, so now this thing is the output of f going into the new input for h. So h of 21, here's h, 9 times 21 minus 2. So 189 minus 2, or 187. All right, in question 9, we have f composed with h of minus 2. So the minus 2 goes into h first. Okay, what does h produce? So I plug minus 2 into h, and out comes minus 5. Minus 5 then goes into function f, which is minus 5 cubed minus 6 times minus 5, and we get a minus 95. All right, in question 10, we chain 3 functions together. We have f of h of g of 5. So you got to start with the inside. 5 goes into g. Okay, well, we find g. G of 5 is square root of 25, which is 5. Okay, so that's the stuff that came out of g. It now goes into h because h is next. So h of 5, here's h. 3 times 5 plus 2, and I get a 17. The 17 now goes into f, and it's 17 cubed plus 4 times 17, and we've got some fairly large numbers. All right, let's see. In question 11, we want to find p of n of x. So they didn't give us a number, it's just a generic x. So this is p of n of x. So the way I start this off is I just fill in, well, what's n? Well, n is x minus 2. So at that point, I have p of blank is blank squared minus 9 times blank. Here's p, right? So all I've done is taken the x's away and put in blanks, because then I can figure out, well, how does this x minus 2 get plugged in? I need to square it, and then minus 9x, and a minus 9 times a minus 2 is a plus 18. All right, so when I square x minus 2, you have to work all of this out. 4 things to multiply. And so we get x squared minus 13x plus 22. And the domain here is everything. All right, and then we begin to look at question 12. Now, what's different about this problem versus the other ones is we don't have the actual rule for the function. All we have is the graph. So the one in blue is the graph for f of x, and the one in pink is the graph for g of x. So we're going to have to read the outputs off of the graph. So for example, here's 1. What would f of 1 be? Well, I go find function f and go back to the y-axis, and that's a 2. So f of 1 would be 2. If I go figure out what does g do to 1, I go look for g. I come down and back, and I get minus 1. So you see here, when I want to find f plus g of 1, I still put 1 into F and G. But then to figure out the outputs, like we just did, we go get them from the graph. And so 2 plus a negative 1 is 1. G minus F of 4. All right, so we're going to need G of 4 minus F of 4. All right, so G of 4. First I go find 4. Here's 4. Now where's G? G is the one in pink, so come up and now over, and G of 4 is 2. What about F of 4? Well, F is down, and that's at a height of minus 1. So 2 minus a minus 1 is 2 plus 1, which is equal to 3. What about G times F of 4? Well, that's G of 4 times F of 4. Now we already found them, so there's nothing new there. G of 4 is 2 and F of 4 is minus 1. F divided by G of 3. So we need F of 3 divided by G of 3. Alright, so F of 3, come here to 3. Now F is right there too. So you go back to the y-axis and that's 0. So F of 3 is 0. G of 3 gives me an output of 1, and 0 divided by 1 is 0. Alright, what about E, F, and G, where we have to do composition? Let's see, F composed with G of 2 means I need F of G of 2. So I start with 2 and figure out what does G do to it. Alright, so here's 2. G is pink, so that means G of 2 is 0. Okay, so G of 2 produces this 0. Now the 0 goes into function f. Alright, so here's 0. Where's f? F is here, and that's at a height of 3. Alright, what about G of f of minus 1? So we start with the minus 1, put that into f. Alright, so here's minus 1. I go find f. F produces an output of 3. Alright, so now the 3 goes into function g. So here's 3. Where's g? G is the one in pink. So g of 3 is 1. And g of f of 1. Alright, so 1 goes into f. What happens? 1 into f, and f produces a 2. Alright, and the 2 now goes into g, and g of 2 produces 0. So it's mainly just reading things off of a graph and tracing out the steps. Let's talk a little bit more about domains. This would not be on a test, but just so that you have the information. So for example, here's f of x, square root of x plus 1, and g of x is x squared. The domain for f has to be minus 1 and bigger, whereas g of x is just a quadratic function, so its domain is everything. So how would you find the domain for f plus g, f minus g, and f times g? Well, the domain is the intersection, or what's in common between these two collections. Well, one of them is everything and the other is minus 1 and bigger. And so the only thing that they both share in common is minus 1 and above. So again, the domain is the intersection of each of the separate domains. You might say, well, what about f divided by g? Well, we just have to remove anything that would make g equal to 0. Well, g of 0 is 0, so I would have to remove 0. It makes the domain for the division fairly complicated. What about the composition? Well, the composition looks like the following. We start off with an x, the x goes into g, g produces g of x. Okay, so once that's produced, f picks up that number and produces something more. Well, here's the hard part. Suppose g of x is x plus 3. Its domain is everything. F of x is the square root of x minus 4. So its domain is 4 and above. Where things get tricky is the following. Suppose I wanted to put 0 into g. That's no problem because the domain for g is everything. And so 0 plus 3 is 3. No problem at all. But the problem is the following. F can't use it. Even though 0 is fine for g and g produces 3, the domain for f starts off at 4. So here's 3 and the domain of f starts off at 4, so f can't pick it up. So that would mean 0 would not be a part of the composition. And again, this is just some knowledge for you to use about the difficulty in composition and looking for the domains.